we're going to get into algorithms, algorithm development. The nice thing about doing this in the same week as Module 8 is that a lot of the stuff we talk about today will be able to support you as you tackle some of the problems in Module 8. Okay, so I want to give you some background information, and then I'm going to talk through a specific application of algorithm development to the Module 8 material, specifically the cleaning of email addresses and how that might look from an algorithmic standpoint. And then we'll wrap up by taking a quick look at the sandbox for this module. So what is an algorithm? That's a good place to start. We hear a lot about the algorithm, right? In the news, the algorithm is out to get us. The algorithm is shaping our view of society. It's ruining our children. It's causing us to have mental health problems. But we don't really know what the algorithm is. The algorithm is just some magical thing that maybe was invented by Mark Zuckerberg or somebody at Facebook that is out to get us by stealing all of our attention away. And that's not totally wrong, right? I mean, Facebook and Instagram and TikTok and all of those social media platforms that use the algorithm are actually making money the more we stare at them. So they have a problem, right? They have a problem to solve. And the problem that they need to solve is, how do I get all of those people out there to stare at their phones more so that I can sell ads to advertisers and make more money? That's their problem. So their solution is an algorithm. And that algorithm says, how can I get people to watch more videos or stay on their phone longer or scroll just a little bit further? And the way they address that problem is through this algorithm that they have grown over time that seems to address that problem by bringing us content that it thinks we're going to like, right? So maybe on YouTube, I watch a cat video, and then all of a sudden I go back to YouTube the next day, and what's my screen full of? Cat videos, right? Or, maybe even on one day I Google, best soap to use for washing my car at home. And then the next day I go to not Google, but maybe I go on Amazon or I go to another website, and all of a sudden it's flooded with ads for not just car wash soap, but the best brushes to wash your car and hoses and pressure washers and all kinds of things. And you're like, I'm being stalked by the internet, right? Some people have even anecdotally shared things online about having a conversation with an earshot of their Alexa, and then they go to their computer to search for something, and poof, magically the thing they were just talking about appears on their screen. Is that real? Maybe a bit of a stretch. But how does that algorithm work? Well, on a very simple level, all it's doing is saying, what did people who watched that video before also watch? So if I watch a cat video, and then I watch another cat video, and then Rudy comes along and his computer and he watches that first cat video, it's going to say, oh, well, before Bill watched the first video and then he went to watch the second video. So maybe if Rudy watches that first video, he'll probably, the odds are maybe he'll like that second video also. Now you take that and you multiply it times a billion, and then you have a pretty robust data set of human behavior that says people who do these things want these things. It's also like on Amazon. I don't know if you shop at Amazon, but if I buy a new computer, a new laptop on Amazon, and then I go back the next day, what's it going to show me? It's going to show me mouse pads and cases for my computer and all kinds of accessories, headphones, and what are other things that people bought when they bought a computer? Because it makes those connections. So that's the algorithm that we're talking about when we use the algorithm, capital A, scary algorithm. That's what it is. But all an algorithm really is just a step-by-step procedure for solving a problem. That sounds pretty simple, right? We make algorithms all the time. You use algorithms all the time. You just don't know that they're algorithms. For example, if I give you this math problem, now nobody wants to solve this math problem, but if I showed you this math problem and I said no calculators, a very small percentage of you can look at these numbers and spit out the answer. But most of us can't, sadly. I wish I could. Most of us have a step-by-step procedure that we follow for solving this problem. Am I right? So we take the 8, we multiply it times the 1, we put the number down here. Now we take the 8, we multiply it times the 3, we put the number down here. Then what do we do? We do the same with the 4. 4 times 1 and then 4 times 3. We put those numbers below the 4, right? Just ringing a bell for all you people who haven't done math in ages by hand. See, I've got a kid who's still doing this kind of math, so I actually have to explain this algorithm every day. Yeah, it's so fun. So we know how to solve this problem using a series of steps that we've been taught. And the interesting thing about this algorithm is that it works no matter what those numbers are, right? I could change it doesn't matter what the numbers are. It's just a generic series of steps for solving a problem. The other interesting thing is that same algorithm can be used to solve. Now, nobody wants to solve this. And if you can do this in your head, then I want to hire you, right? Because you're obviously a genius. I don't know what I want to hire you to do, but it's going to be good. We'll figure it out later. It doesn't matter if you can do this in your head. But if we had to, we could solve this problem, right? And it's the same steps. It's the same thing. I start with the 8, then I multiply it all the way across. And then after that, I do the 9. And I line up these, and then I have a massive, like 10-story addition problem at the end of this. But I could solve it. And so the algorithm for this, right, is the exact same thing as the algorithm for this. It's very interesting. We don't think about it, but that's literally what the algorithm is. It's the series of steps that we use to solve a particular problem. And when we build an algorithm, we can say that it's a robust algorithm when it's able to solve a wider variety of problems. So this multiplication algorithm that we use can work on any set of numbers, but it also will accommodate any two numbers that we want to multiply, period. And with a little bit of addition or a little bit of expansion, we can have it do decimals. We can have it do all kinds of negative numbers. I think if we add a few more rules, then we can do that too. So our algorithms are everywhere. We have all kinds of things. When you load the dishwasher. Now, just the other day, I posted to Instagram a picture of my dishwasher because I'm that guy at our house. And my kids had put like a dish on one side, and then they had put it like another dish in the middle, and then another dish was kind of like over here like this. And I just posted it and I said, hey, does this bother anybody else? And I got a massive flood of responses from people who were like, yes, that absolutely bothers me. Because my algorithm for loading the dishwasher says you start on one side and you do every slot so you can put, because I'm interested in running the dishwasher as little as possible, because I'm not also the guy who has to empty it and put all the dishes away. So my algorithm for loading the dishwasher says I do it a certain way. And so I'm a successful parent when I can have all of my kids using my algorithm for loading the dishwasher. Theirs says, I just want to get this over with and put it in there, and it doesn't matter where it goes because magically, no matter where I put it, the dishes all end up clean and back in the cupboard. So their algorithm is maybe a little bit incomplete, let's just say, because their algorithm, when they move out, is not going to work that well.